Hello, calculus students. In this section, section 2.5, we want to discuss limits at infinity. Now, that's not the same thing as infinite limits, which we discussed in section 2.4. Infinite limits are essentially vertical asymptotes. So, as you approach a specific number for x, the function f of x or g of x or whatever will head towards infinity. But this is saying what will happen as x goes to infinity itself or x goes to negative infinity. In other words, what's the ends behavior of this graph? And I mean that on either end. So I'm going to put ends there, right? Because it could be the left end or the right end. So this is saying x is going off to the right of the graph, and this is saying x is going off to the left. So I'll just put those words right here. All right. So the first thing we want to look at is example 1, and I actually put a little a next to it because I misnumbered my examples, but that's all right. So we'll call this 1a, and we want to look at the graph of x equals e to the negative x as x gets very, very large. Okay, so I have that graph drawn in Desmos. One second. And it's linked to right here in the notes for the class materials page. And there we have it. So this is e to the negative x. And you can see that as x gets really, really, really large, we're heading closer and closer and closer to 0. And you can kind of see it if I move the graph over for Desmos. See how the number on the right, that y value, is getting smaller and smaller and smaller. And even if Desmos says it's 0, which it isn't saying it on my screen, but even if it does, that's just the computer giving up. Right? Because it really never reaches 0. It just gets closer and closer to 0. So as x gets infinitely large, the graph of f of x, or the f of x value, and therefore the graph, will get closer and closer to 0. So let me draw that on our notes. So I'm going to draw, let's see, a little axis here. I don't need to see any negatives, right? And then this is roughly the graph of f of x equals e to the negative x. And so we can say that as x gets really large, over here you can kind of see it, right? As x goes to infinity, f of x goes to 0. Right? Just on a side note, on the other side, it's actually going off to infinity. So as x goes to negative infinity over here, as x goes to negative infinity, f of x is actually going to positive infinity. So it's shooting up, up, up over here. So that one doesn't really give us anything good. But this part right here, this orange part, that is giving us something good. Namely, that we can see that we have a horizontal asymptote. So this right here is telling us that we have a horizontal asymptote of 0 for this graph. Sorry, I can't spell. Horizontal asymptote. And there we go. Wonderful. Okay, so that leads us to our first definition right here, which is that when you have the limit at infinity and you get a value, so you can have a limit on the high side, right? So as you go to the right, as you approach positive infinity, your function is approaching a particular value. That's what actually happened to us in this graph right here. So we were approaching a particular value. As x went to infinity, the f of x was approaching 0. So for us, 0 was this limit L, and therefore that was our horizontal asymptote, y equals L. Now, it didn't happen to us on this particular graph, but it could also happen that as x approaches negative infinity, your function is approaching a value, which would mean y equals L is also a horizontal asymptote, but for the left-hand side. Now, it is possible that you have a horizontal asymptote on the right and a horizontal asymptote on the left, and they're the same, and it's possible that they are different. So I'll make a note of that really quickly. There. So it is possible. It doesn't happen super often. More often than not, they're the same, but they don't have to be. So if they are the same, so be it. If they're not the same, then that's fine. But just a little note that it is possible. Okay, so let's find the limit of this function analytically, every calculus student's favorite word, because that means that they're going to actually have to show some work. Okay, so if I want the limit of this, what I really want is the limit as x goes to infinity of each piece of this. So I could take 3 and divide it by x squared, and then I take 2x and I divide it by x squared, and then I take 4x squared and I divide it by x squared. All right. Well, that means that I really want, now let's think about this for just a second. These two are going to have a little bit of division because, for example, x squared over x squared divides away and makes 1. Then the x divided into the x squared, and it's going to just leave us x in the denominator. So that means that we're really taking the limit as x goes to infinity of 3 over x squared plus 2 divided by x plus 4. Okay, now we want to think about this a little bit logically. If you have 3 of something and you want to divide it amongst infinity squared, what does everybody get? Well, 3 divided by infinity would be a big 0. And 2 divided by infinity would also be 0. So what you would have is 0 plus 0 plus 4, which last time I looked, 0 plus 0 plus 4 would be 4. And so that would be our limit. And for the record, they didn't actually ask for it, but that would also mean that y equals 4 is a horizontal asymptote for this graph. Oop, this graph. I can't spell. Oh my goodness. Hold on one second. There we have it. Now I'd like to just back myself up here a little bit with Desmos. I want to make sure that what I'm doing here is correct. So let me bring up Desmos real quickly. And then actually the class materials page, because this is example 1B. So I'm going to pull this up. And there we have it. So you can see this is the graph right here of that function. And in case you don't believe me, there it is, 3 plus 2x plus 4x squared over x squared. And you can see the horizontal asymptotes right there. Now, I often get students thinking that you cannot cross, the graph cannot cross a horizontal asymptote. That's not true. That's true of vertical asymptotes, but not horizontal asymptotes, because this is a function of x. So you can cross your horizontal asymptote. You can intersect with that horizontal asymptote. As a matter of fact, I am in this particular graph right here at that point. But you can also, right there it is, that black dot. But you actually could cross it infinitely many times. You actually could have infinitely many intersection points. That's okay. So just keep in mind, horizontal asymptotes and vertical asymptotes, not the same thing. So a vertical asymptote you cannot cross. You cannot have an x value there. Well, I shouldn't say that. That's not even true. You just can't have it if your limit is infinity from both sides. Or from the left and the right, you're both heading towards positive or negative infinity. Okay, but a horizontal asymptote, you absolutely can intersect with a horizontal asymptote, no problem. So you would just have an intersection point. Right? Now, that's not to say that all graphs do, but some graphs do.